A quadratic function models the projectile's height in meters above the ground in terms of the time in seconds after it was launched. The model estimated the projectile was launched from an initial height of 7 meters. So we're starting from the 7 meters above. So let's say we have ground here. We have ground and we are 7 meters above. Okay, so this is like a 7 meters. I think like we have a platform up here. And 7 meters is about like maybe like 23 foot, something like that. Okay. And reached a maximum height of 51.1 meter above the ground 3 seconds after the launch. So it's like as if you have ball here and it's gonna go up high and it's gonna have a parabolic trajectory. Again, the highest happened at 3 seconds. So if you call this as t and this as a height, okay, this is a function you get. How many seconds after the launch does the model estimate the projectile will return to height of 7 meters? So I'll teach you the fastest way. This is easy if you understand that the parabola or quadratic function is symmetrical to the line of axis. So if I draw the same height on the other side of the trajectory, it takes the 7 meters. To get the same height for this ball to travel and then reach the same height from the ground, 7 meters above the ground, you just have to know that if it takes 3 seconds to go up, it will take 3 seconds to go down. Now, if there's a like air resistance, then it will be different problem, or it won't be exactly 6. But we're doing math here, and they never talk about air resistance, so it's just 6 seconds. Okay, so if you think it that way, it's really easy question. They call it difficult, 3 out of 3 here, but it's just 6. Use the symmetry of the quadratic function as much as you can. Now let's say you want to do analytically and your brain is not working on the test day and you just want to do like how you were taught in math class. Alright, we can do it too. Okay, so this is method 1. I highly recommend you do this. Now method 2, sure, we can use this point, the maximum 3,51.1, and that's 3 seconds. And from that, and knowing the y-intercept at 0,7, I can just write down the Vertex formula. Y is equal to a x minus t squared x minus 3. Actually, if I chose h, I should say h as a variable y. X minus 3 plus 51.1. So it came from like y equals ax minus h squared plus k. Okay, that's the Vertex form, the generic form. Now I plug it in the x coordinate 3, being the x coordinate of the maximum, and then the y coordinate 51.1 here. Okay, I still need to find a here, so to do that, I can plug in 0 and 7. So when you put x equals 0, I'm supposed to get 7 for height. Now negative 3 squared give you 9, 9a plus 51.1 is equal to 7. Subtract 51.1 on both sides. And you get 9a is equal to negative 44.1, and you just have to divide by 9. Again, this takes a lot of time, so I don't recommend it. So I plug this value into the formula up here where the a is. So I get h is equal to negative 44.1 divided by 9 x minus 3 squared plus 51.1. We want to come back to the height of 7 meters. So when you replace a height equals 7, now the rest can be done on calculator. Where Wait a minute. Oh, one thing to be careful, I just realized that the height is 51.1. Never mind, I use the ground as the... I almost got tempted to subtract the difference here, but since the since our reference is the ground level, so yeah, this should be fine. So when you subtract 51.1 on both sides, you're gonna get negative 44.1. So you can see the negative 44.1 will cancel out. They cancel and multiply 9 on both sides. And then you square root both sides. Well, technically you get absolute value of x minus 3, but we will ignore the negative 3 here. So just get 3 and x minus 3, and x equals 6. So you can also get that. Well, technically it should have been t, right? Yeah. But you get the idea. You get 6 seconds, but like I said, or like I showed you guys, this takes a long time. So again, try to take advantage of the quadratic functions, line of symmetry. So if it takes only 3 seconds to get there, it will take another 3 seconds. Okay, this is assuming there's no air resistance and so forth.